Naples Supervolcano is reaching dangerous levels. They say it could have been the reason that the Neanderthals became extinct. This is a satellite image of the area of Naples. Campi Flegrei is what we see on the 10 o'clock position. That little bay area is Campi Flegrei, and that nipple of a thing at the 2 o'clock position is the volcano, Vesuvius volcano. Now, if you look closer, we will look closer, but in the 10 o'clock position of the Campi Flegrei, you'll see what looks like little bowls. Those are actually craters of the supervolcano. This whole area is a supervolcano. And there are cities here. There are at least 500,000 people living in this area. Scientists warn that Campi Flegrei eruption would be catastrophic for at least 1.5 million people in the whole region. Scientists discovered a hot zone feeding a supervolcano near Naples, southern Italy, and it's prompting fears it is nearing eruption. Campi Flegrei, a volcanic caldera to the west of Naples, last erupted centuries ago, and it has been quiet ever since the 1980s, when the movement of magma into the volcano's shallow chamber caused a series of small earthquakes. Seismographic data from those tremors now allowed scientists to pinpoint the source of the magma that entered Campi Flegrei's chamber and caldera, actually the hot zone. And the analysis of this zone shows that the supervolcano is becoming more dangerous. Quote, "One question that has puzzled scientists is where magma is located beneath the caldera, and our study provides the first evidence of a hot zone under the city of Pozzuoli that extends into the sea at the depths of 4 kilometers." End quote. This is what Dr. Luca De Siena, leader of the study at the University of Aberdeen, Scotland, stated, and he added, "While this is the most probable location of a small batch of magma, it could also be the heated fluid-filled top of a wider magma chamber located even deeper." His research shows magma was blocked from rising to the surface in the 1980s by a 1 to 2 kilometer deep rock formation, which forced it to release stress along a lateral route. It's not yet clear what this means for the volcano in the future, but the relatively low amount of seismic activity in the area in the last 3 decades suggests that, in effect, pressure is now building within the caldera because the earthquakes are not releasing this pressure. Dr. Siena said, quote, "What this means in terms of the scale of any future eruption we cannot say, but there is no doubt that the volcano is becoming more dangerous." End quote. The eruption can occur when the pressure of molten rock causes the ground to stretch to a breaking point, which would be catastrophic for the 1.5 million people living around the Naples region. Dr. De Siena explained, "During the last 30 years, the behavior of this volcano has changed, with everything becoming hotter due to fluids permeating the entire caldera. Whatever produced the activity under Pozzuoli in the 1980s has migrated somewhere else. So the danger does not just lie in the same spot, it could be now much nearer to Naples, which is more densely populated." Dr. De Siena described Campi Flegrei, which translates as burning fields, as being like a, quote, "boiling pot of soup beneath the surface," end quote. The volcano's most famous eruption, the Campanian Ignimbrite eruption, happened about 39,000 years ago, and it spewed molten rock around 70 kilometers into the stratosphere. That's pretty high up. This eruption was the largest Europe has seen in the last 200,000 years. It may have played a part in the extinction of the Neanderthals. The magma transfer at Campi Flegrei caldera, Italy, before the 1538 AD eruption. This is what we said was that had erupted 500 years ago. 1538 AD was that eruption. The calderas are collapse structures related to the emptying of magmatic reservoirs. Now we can go into this because we can learn what's happening in Kilauea. This is what happened at the crater of the Kilauea summit. We saw the collapse, and it was reported that it was at least twice as deep as it was when it was first reported by the first settlers in Hawaii, the Caucasian, the American settlers. So that's what we saw in the Campi Flegrei caldera as well, that the calderas are collapsing structures related to the emptying of the magmatic reservoirs. We see this here, often associated with large eruptions from long-lived magmatic systems. Understanding how magma is transferred from a magma reservoir to the surface before eruption is a major challenge. We exploit the historical, archaeological, and geological record of Campi Flegrei caldera in order to estimate the surface deformation preceding the Monte Nuovo eruption and investigate the shallow magma transfer. And the data suggest a progressive magma accumulation from 1251 to 1536 in a 4.6 plus or minus 1 kilometer deep source below the caldera center, and its transfer between 1536 and 1538 to a 3.8 kilometer deep magmatic source, 4 kilometers northwest of the caldera center below Monte Nuovo. This peripheral source fed the eruption through a shallow source. This is the first reconstruction of pre-eruptive magma transfer at Campi Flegrei and corroborates the existence of a stationary oblate structure, a source, below the caldera center that's been feeding lateral eruptions for the last 5 Ka. The results suggest 1. Repeated emplacement of magma through intrusions below the caldera center. 2. Occasional lateral transfer of magma feeding non-central eruptions within the caldera. Comparison with historical unrest at calderas worldwide suggests that this behavior is common. In historical times, only 2 felsic restless calderas have erupted, Campi Flegrei and Rabaul. Campi Flegrei is a densely inhabited metropolitan area of Naples, Italy, and is commonly considered one of the most dangerous active volcanic systems. Campi Flegrei is a 12-kilometer depression hosting 2 nested calderas formed during the eruptions of the Campanian ignimbrite, and that's about 39,000 years ago, and the Napolitan yellow tuff 15,000 years ago. In the last 5,000 years, resurgence with uplift of about 60 meters, that's close to the central part of the caldera, was accompanied by volcanism of the third epoch of activity. That's 4.8 thousand to 3.8 thousand years ago. After 3,000 years ago, 3,000 years of quiescence, several decades of increasing seismicity and uplifting preceded the last eruption at Monte Nuovo in 1538. The most recent activity accumulated in 4 unrest periods between 1950 to 52, 1969 to 72, 1982 to 84, and 2005 to the present, with uplift at Pozzuoli of about 1.8 to 0.3 meters, respectively. And the present unrest episode has been interpreted as being magma-driven. So the unrest now is being magma-driven. These unrest episodes are considered the most evident expression of a longer-term restless activity. The post-1980 deformation largely results from a magmatic oblate or sill-like source. However, an important role for the hydrothermal system has been also proposed. Despite the restless activity of Campi Flegrei, the recent unrest episodes did not culminate in eruption, so that any possibility to define the pre-eruptive shallow transfer of magma, that is, from the magma reservoir to the surface at Campi Flegrei, remains elusive, and this definition is a crucial step in order to identify and understand pre-eruptive processes and to make any forecast. To fill the gap, we focused on the last eruption of 1538, reconstructing its pre-eruptive deformation patterns. And for this, we exploited the unique historical, archaeological, geological, and long-term geodetic records of the caldera to carefully determine the height variations of 20 selected sites along its coastline. The details of this complex and multidisciplinary approach are provided in the methods and the supplementary information sections. The paper, a completely original data set, is provided on the height variations within the Campi Flegrei caldera in the last 2,000 years, with the only exception for the previously known vertical displacements at Site 30. While our collected data span the last 2,000 years of evolution of the caldera, in this study we focus only on the deformation occurring 300 years before the 1538 eruption, when the centuries-long subsidence of the caldera reversed into uplift. And the results: elevation changes within the caldera. The integrated analysis of geomorphological and sedimentological, paleontological, archaeological, and historic data allowed a detailed and quantitative reconstruction of the evolution of the ground displacements predating the Monte Nuovo eruption along the coastline of Pozzuoli. A representative example of the multidisciplinary procedure adopted for such a detailed description of the historical elevation changes for the Capo Miseno area is in the material. General results of the analysis shows the historical elevation changes from 35 BC to the present at the sites along the coastline of Pozzuoli Bay. These data show that in 35 BC, the coastline extended outward into what is now the Pozzuoli Bay. However, since then, all the area started to be affected by a quick subsidence, which resulted in a progressive submersion of the coastline until 1251. The amount of subsidence and the investigated areas varies from place to place as well, documented by the presence of geomorphological, sedimentological, and paleontological indicators. Subsequent progressive immersion of the area started during the 13th century, as suggested by historical and urban planning sources, archaeological evidence, and geological data. The lower time limit for the caldera uplift is given by historical documents describing the Pozzuoli promontory as an island in 1251, whereas at the end of the 13th and the beginning of the 14th century, the previously submerged area around the promontory is reported as the location of 3 new churches. Moreover, coeval urban studies testify to the expansion of Pozzuoli on new land formed by the coastline regression, confirming the onset of a long-term uplift. Since sea level variation in the last 2,000 years has been in the order of about not even 3 feet on average, the much larger immersion of the area from the 13th to the 16th century is mainly due to the ground uplift, with the maximum values recorded in the Pozzuoli area. The uplift rate was quite low, about 1 centimeter per year, from the middle of the 13th century to the 14th century, and increased to about 9 centimeters per year from 1400 to 1536. That was just before the eruption. During this latter time span, all the coastal strip emerged in response to the generalizing uplift of the caldera floor, whose maximum of 12.3 meters has been recorded again in the Pozzuoli area. Since the end of the 15th century, this uplift was accompanied by strong seismicity. Okay, so they had an uplift and earthquakes, strong earthquakes. I knew a stronger uplift with a rate of, that's about 1 meter per year. That's about 3 feet every year, following the previous one between 1536 and 1538, reaching a maximum value of 19 meters. 19, let's say 20 meters times 3, that's 60 feet. In the future vent opening area, Mount Nuovo. 60 feet. This highest rate uplift was accompanied by very intense seismicity, which affected all of the Pozzuoli area and was felt also in the city of Naples. And indeed, all the historical sources coeval to eruption report an evident uplift accompanied by seismicity and opening of fractures in the vent area during the 2 days that preceded the eruption. Okay? You had the fissures and the fractures in the vent area before the eruption. The error associated with the height estimate up to 1536 is relatively low. We therefore use this year to distinguish the long-term caldera deformation from the short-term deformation preceding the eruption, from 1536 to 1538, reconstructing from several sources almost coeval with the eruption. In the evaluation of the short-term deformation, we do not take into account the deformation occurring approximately 2 days before the onset of the eruptive activity, in order to exclude any contribution from the emplacement of the dike feeding the eruption. However, due to the very rapid deformation, the evaluation of the total amount of deformation in sites close to Monte Nuovo in the days before the eruption is affected by a large error, about 3 meters. After the eruption, all the recovered deformation data show a generalized renewal of the subsidence with maximum values in the Pozzuoli area. The nature of the data makes it difficult to precisely infer the amount of the extent of horizontal deformation that accompanied the vertical deformation. However, records of ground tilt offer an additional constraint on the deformation field. To this aim, tilt changes between 1536 to 1538 have also been reconstructed. I'll leave a link below for you for this. This is a very long article, and you can see various maps, again, of the Bay area there, of the Campi Flegrei, and their discussion and conclusions. So this, as we said, is a supervolcano. And that's what they're very apprehensive about. Now, is Italy's supervolcano about to blow? Yes, experts are warning that Campi Flegrei is at a critical stage in the build-up to the devastating eruption. Campi Flegrei is a supervolcano located outside the western suburbs of Naples. Its last devastated eruption was 1538, following a century of unrest. The volcano has been restless again since 1950 with regular earthquakes. There is now a build-up in energy in the crust similar to the 1538 eruption, and if it does erupt, experts believe it would affect at least 360,000 people living across the caldera and Naples population of nearly 1.5 million people. The critical stage, unrest since the 1950s, has been causing a buildup of energy in the crust, making the volcano more vulnerable to eruption. And until now, scientists had thought that the energy needed to stretch the crust was lost after each period of unrest. The episodes of unrest are caused by the movement of magma around 3 kilometers below the volcano. An eruption becomes more likely when the ground has been stretched to the breaking point. This is because the molten rock can escape to the surface when the ground splits apart. But it's difficult to pinpoint when an eruption will occur, because even if